In this final video from Chapter 5, we're going to put it all together, learning all of the methods of using probability that we've learned from sections 5.1 all the way through 5.5. So you'll have to know just from reading a particular question what type of method you're supposed to use in order to solve the question. For example, Sean is planning for college and takes the SAT test. While registering for the test, he is allowed to select 3 schools to which his scores will be sent to at no cost. If there are 12 colleges he is considering, how many different ways can he fill out the score report form? Well, this is asking me how many ways, so this is a counting technique. So out of the counting techniques, we're asked to find which one of these different ways are we supposed to select. So ask yourself, does order matter? In the question it says that he's allowed to select 3 schools out of 12 in order to send his SAT scores to. So does the order matter in which the 3 schools are selected? The answer is no. It does not matter because the SAT scores are going to get sent to all of the schools in the order in which they receive them does not matter. So we're dealing with a combination. So this is going to be a combination of 12 total schools, and we're supposed to take 3 out of those 12 schools in order to determine how many ways we can send out those results. So in our calculator, we can simply just do a 12 combination 3 at a time, and we'll find that the answer is 220 different ways. An essay test in European history has 12 questions. Students are required to answer 8 of the 12 questions. How many different sets of questions can be answered? Well, again, this is a counting question because it says how many sets. So if we go back again, we have to ask ourselves whether order matters. And it says the test has 12 questions and you're required to answer 8 of them. How many ways can you answer those 8 questions? Does the order matter in which you select the 8 questions in order to complete your test? And again, the answer is no, it does not matter, so this would once again be a combination. The teacher is going to grade the exam based on the 8 answers you answered, not the order in which you answered them. So this is a combination. There are 12 total questions, and we're asked to pick 8. So if we're going to put this in our calculator, we have a n of 12 combination of our items, and we're going to end up with 495 ways to answer the questions on that test. Now number 3 is a little tricky. It says how many ways can 3 men and 3 women be seated around a circular table that seats 6, assuming that women and men must alternate seats. So what we have to do first is we have to pick the women. So if we look at a table and you have 6 seats, right? 1, 2, 3, 4, 5, 6. And we know that women have to alternate seats. So we know that women have to alternate and men will then sit in between them. And it says how many ways can 3 men and 3 women be seated, assuming women and men must alternate? Well, we could do this in 2 ways. We could do this using just the multiplication principle. So when a woman walks into the room and she finds her first seat, she has one of 3 different seats for which she can sit in. Then the next woman comes in, assuming the first woman sat in this chair. When the next woman comes in, she's going to find one of these 2 remaining chairs, so she's only got 2 options. She might sit here. Well, the last person that comes in does not have any freedom in the choice to be able to pick where she wants to sit. She must sit in this chair, so she only has 1 option. Then the man comes in. The first man comes in, he says, okay, I'm going to sit in this chair. So he has one of 3 different chairs for which he can sit into. When the next gentleman walks in, he has 2 choices. He might sit here And when the last gentleman comes in, he only has one seat to sit in. In other words, he has no freedom of choice. So when we multiply all of these together, we're going to get 36. 36 possible ways that they can sit in those chairs. Another way you can do it is using permutations. Since order does matter, clearly if Alice, Barb, and Christy can sit in this order, we could also do Alice, Barb, and Christy. So order does matter because those are different arrangements. So this would be a permutation, and each woman has 3 seats to sit in, and we're going to sit all 3 women. But then we're going to go back into the hat, and now we're going to select 3 men out of a group of 3 men. And when we multiply this in our calculator, we should get the same answer. $36. Number 4. If the 2011 Hyundai Genesis has 2 engine types, 2 vehicle styles, 3 option packages, 8 exterior color choices, and 2 interior color choices, how many different Genesises are there possible? Well, we first have to decide, again, whether this is a permutation or combination. And since this is going to be a permutation, we're going to be using the permutation with distinct items with replacement, which is just basically using the multiplication principle. So the multiplication principle is also like using a factored tree. So if you walk in to the Genesis dealer and you said, okay, I have one of 2 engine types to pick from. I'm either going to pick this engine type or this engine type. Then you have to pick the vehicle style. Well, there are 2 vehicle styles for which you can pick from. Then you have to pick one of 3 option packages. So there's 3 option packages for each of these. So we're already up to 12 possible options. But I still have to pick 8 exterior color choices and 2 interior color choices. So you can see that this is going to get quite big quite fast. So the easiest way to do this is to multiply using the multiplication principle. I have 2 engine types, 2 vehicle styles, 3 option packages, 8 exterior color choices, and 2 interior color choices. And when I multiply all those together, you get 192 possible combinations of vehicles to choose from. Peyton's futsal team consists of 10 girls, but only 5 can be on the field at a time. There are 4 fielders and a goalie. How many starting lineups are possible if all players are selected without regard to the position being played? Well, does the order matter in which the 5 are selected? And the answer is no. This is a team of 5 players. It doesn't matter who's selected first versus last. They all go on the field. Since this is a combination, we know we have a total team of 10 girls, and we need to select 5 out of the 10. There are 252 combinations of players to determine who goes on the field. Now, what if we say in the starting lineup, Peyton or Jordan must play the goalie? Well, there's going to be 2 events happening here that we're going to multiply together. First, let's pick a goalie. So it doesn't matter the order in which the goalie is picked, and we need to pick one goalie. And we're going to pick that one goalie out of a team of only 2, because these are the only 2 ladies that know how to play goalie. So out of the hat of goalies where Peyton and Jordan's names are in, we're going to pick one name out of the 2. Then we go back into the other hat, and now we have to pick the remaining 4 players. Now we're assuming if Peyton was picked for goalie, Jordan's not going to be picked for the rest of the positions. If we assume Jordan then won't be in the other hat, we are only left with 8 possibilities. So the question was a little unclear whether Jordan was going to be replaced into here or not. When I multiply these together, I'm going to get 140 possible ways to determine whether Peyton or Jordan will be the goalie, and then we have 4 out of 8 possibles left. So we drastically reduced our number of ways of picking a team from 252 down to 140 if we're being more specific that these 2 people must be one of the goalies, and the other 4 will be picked from the remaining 8 people. So you can see that these numbers definitely go down when we become more specific. Number 6. Let's say you have 10 marbles in a bag. 5 are yellow, 3 are red, and 2 are green. What's the probability of selecting a yellow marble? Well, how many total marbles do we have? 10. Out of the 10 marbles, how many are yellow? 5. Okay, so you have a 50% chance. What is the probability of selecting a red marble and then a green marble? Remember, and means multiply as long as they're independent events. But now we're assuming without replacement. So we're going to multiply the probability of getting a red marble first. So we have 3 out of 10. Then we go back in the bag. We're not going to replace the marble. So that means we now only have 9 marbles left. How many green marbles are in the bag of 9 marbles? 2 green ones. So this is going to give us a 6.7% chance of occurring. What is the probability of selecting 2 non-red marbles, one after the other, without replacement? So again, we're going to select 2, so that means we're going to multiply the probability of the first event, then we go back in the bag and select the second event. So the probability of selecting the first non-red marble. Well, out of the 10, how many of the marbles are not red? All the yellows and all of the greens. So that's 7 because there's 5 yellows and 2 greens. Now, we're going to take one of them out, right? Let's say that it was yellow and we take that out of the bag. Now we go back into the bag. Now there's only 9 marbles. How many non-red marbles now are left? Well, since I took one away, I now only have 6. This leaves us a 46.7% chance of picking 2 red marbles. What is the probability of selecting 1 red marble when choosing 2 marbles? So I want to know what the probability is of selecting at least 1 red marble. Well, the word at least means 1 or more. So I'm really looking at the probability of choosing 2 red marbles, a red and then a non-red marble, or a non-red marble and a red marble, because at least 1 red marble can fall under all of those categories. So I have to find each of those individual probabilities and then add them all together. Well, the probability of selecting a red and then another red marble would be 3 out of 10 times 2 out of 9. How about a red and then a non-red? Well, the first red would be 3 out of 10, and then a non-red means there will be 7 non-reds out of only 9 left over. Plus the probability of selecting a non-red marble and then a red marble. And when I multiply all of that together, I'm going to get 53.3%. Now there's another way I could have done this problem. Another way I could have done that is instead of selecting all of these and adding them together, I could just select the probability of selecting 2 non-red marbles and minusing that from 1, since that's going to be the complement of all of these. These are the only 4 possible outcomes. The probability of selecting 2 non-red marbles we just found up above, which is 46.7%. It was 7 over 10 times 6 over 9, which ends up getting us the exact same answer. There are currently 54 Republicans in the Senate, 44 Democrats, and 2 independents. 6 members are chosen for a committee. How many ways can this be done? Well, this is a counting technique where the order does not matter since they're all just chosen for a committee. Since this is a combination, we're going to select a total of 6 members out of a group of 100. A combination was going to equal out to 1,192,052,400 possible ways that you can select 6 out of 100. Quite a large number. However, let's be more specific. What if I say, what is the probability that the committee will consist of all Republicans? So since we're looking for probability, that means I need to divide. This will be my denominator. This is the total number of ways of selecting anybody, regardless of their party designation. On the top, I specifically want to select all Republicans. So I'm going to select the 6 out of the Republican group, so it's only out of the 54. And when I put that into my calculator, you're going to get only a 2.2% chance that that will occur. We would also consider this unusual. What is the probability the committee will consist of 2 Republicans and then 3 Democrats and then 1 independent? So these are 3 separate events and we have to multiply all of them together. Remember, our denominator, we're still selecting 6 out of 100. But in the numerator, we have to go back into the hat 3 separate times to select people from 3 different parties. So first we're going to go into the hat and we want to make sure we select 2 Republicans. So we're going to select 2 Republicans out of the group of 54. Then we go back into the hat and we select 3 Democrats. So we're going to select 3 Democrats out of the group of 44. Then we go back into the hat and we select 1 independent out of the group of 2 independents. When we multiply these together and divide by the total sample space, we get 3.2%, which is actually more likely than selecting all Republicans. However, it is still an unusual event. Last question. Let's use some of the statistical notation for this one just to make sure that we understand how this notation is working. Approximately 0.1% of the current U.S. population has lung cancer. 90% of lung cancer cases occur in smokers. 21% of people who do not have lung cancer do smoke. Let's let event S be the smokers and event L be the people who have lung cancer. Find the following probabilities. So this is asking us what is the probability that someone will have lung cancer. So we go back up to the question and find the probability that someone will have lung cancer. It says right up at the top that 0.1% of the current U.S. population has lung cancer. So 0.1%, or as a decimal, is 0.001. This is saying what is the probability that someone will smoke given you know they've already had diagnosed with lung cancer. So right here, the second sentence that's written says 90% of lung cancer cases are smokers. So it's saying if I know that they have lung cancer, 90% of all lung cancer cases are going to be smokers. So if I already know that they have lung cancer, there's a 90% chance that they also smoke. So this is 90%, which is also 0.9. The third question, part C, says what is the probability somebody will smoke given you know that they don't have lung cancer? And that's written up here. It says 21% of people who do not have lung cancer do smoke. So it's going to be 21%, which is 0.21. And lastly, what's the probability somebody has lung cancer and smokes at the same time? Well, remember, in order to AND, we multiply. We would multiply the probability that someone has lung cancer times the probability that they smoke. But since these are dependent events, we have to multiply by the probability that they smoke, given you know that they already have lung cancer. And we have both of these pieces of information already designated up here. The probability of lung cancer is 0.001. The probability of smoking, given you have lung cancer, is 0.90. So when I multiply those together, I get 0.0009, which is 0.09%.